Okay, let's start. I am Engineer Ramon Pitao from Biliran Province State University. I am currently acting as a chairperson for the Mechanical Engineering Department. So for now, we are discussing about air standard power cycle. So this is the theoretical cycle, and by the way, what is the air standard power cycle? So air standard power cycle are the cycle that use as the working medium, or you use air as the working medium. Actually, this is not purely air, but it considered air in theoretical analysis, or in theoretical cycle. That's why in these slides we use the term theoretical cycle. Okay, so again, air standard power cycle are the cycle that use air as the working medium. In our analysis, we assume all that air passes is perfect gas with constant specific heat. Through the process, heat is supplied from a constant high temperature source, and there are no losses from the surrounding. So we assume here as an reversible process. All the components are reversible process, and there is no losses to the environment. That is why it is purely theoretical. Take note from the word theoretical. Okay, so and also in this cycle we use air. We assume, or we use air as a theoretical. We use air na ating gagamitin na sa working substance. Okay, first we have in the air standard cycle, first we have a Carnot cycle. Carnot cycle is the most efficient cycle, ika nga, 'di ba? Alam naman natin na yung pinakamataas na efficiency sa lahat ng cycle sa Carnot cycle or Carnot cycle. Engine can be compared with these cycles to determine its degree of perfection. Meaning, ito yung basihan, basis, pinaka-top siya. So, meaning, pinaka-top siya, basihan siya, ito yung basis ng pagkuha ng efficiency. Like, for example, kung pupunta ka ng Ericsson cycle, pupunta ka ng Stirling cycle, ito po yung babasihan mo as a perfection of degree. Okay, nandito na. Okay, so nakikita natin ngayon, yung graph ng, of course, pag sinabing cycle, may mga graph yan para makita mo kung yung kabuuan ng cycle from start to finish, or from start hanggang sa bumalik siya sa original state niya. So dito may pressure and volume tayo na graph. Mayroon din tayong temperature versus entropy graph. If you notice, parang parang tinapay po yung PV. Ito din na naman rectangle yung graph. Papakatandaan lang po niyo na ganito yung graph niya. So ito, from process 1 to 2, this is isothermal heat addition. Yan po, nababasa nyo, nakikita nyo naman ng cursor, heat addition, meaning dito po nag-start siya. Of course, pwede ka kahit saan ka mag-start, pero i-consider mo lang yung process, kung anong process na yan, isothermal ba, isentropic ba. So dito 1 to 2, this is a isothermal process. Okay, isothermal process. PV is equivalent to C. PV is equivalent to C. Bakit PV is equivalent to C? Because from that formula, P sorry so from the formula, PB is equal to C, because supposed to be may T yan dito, di ba? May T. Pag 1 yan, 1 po din to. Pag PB, pag 2 to 2, mayroon din 2 dito. So, ika nga, PV over T or P1 V1 over T1 is equivalent to P2 V2 over T2. So, since temperature is constant sa ating process 1 to 2, T1 is equivalent to T2. So, makakancel po siya. Cancel po. So, cancel yung temperature natin. So, that's why 1 to 2 processes PV is equivalent to C. 2 to 3, that is the isentropic process or expansion. Ito po, mayroon po tayong dalawang temperature, mayroon po tayong dalawang entropy na constant pag sinabi natin Carnot cycle. Tandaan lang po, pag yung hint clue, yung pag Carnot cycle ay constant temperature and constant entropy. Ito po yung constant entropy, expander at saka compressor. Pag sinabi ng expander, pwede rin po yan turbine because turbine is expansion ang process, isentropic expansion. So, sa 3 to 4 naman po, isothermal heat rejection, meaning yung heat po natin ay tatapon po dito. Tatapon po yung heat natin. Saan tatapon? Papunta sa environment. Q rejected. QR. So, dito, heat, sorry. Dito, heat addition siya. Sa 1 to 2, Q is A, added. So, nakita nyo yung flow, yung cycle, papasok yung heat sa system, 2 to 3, dito, 2 to 3, papasok sa system, dito, lalabas, yung work of the turbine, papaikutin siya, dito, i-reject niya yung heat, dito, i-reject niya yung heat dyan, dito naman i-compress siya, so, pag na-compress na po yung heat, babalik na naman sa normal state. Okay? So, ganyan po yung kuan natin. Ganito po yung Carnot cycle natin. Ito naman yung equation. So, from PVT relations sa process 1 to 2, isothermal heat addition process. So, sa isothermal heat addition process po, ito po, na-cancel po yung temperature na supposed to be may PV over T1 yan, P2 V2 over T2 yan. So, ganito yan po yung equation niya kasi constant temperature nga. So, please do the math na lang, because that is algebra lang naman yan eh. So, 2 to 3 from isentropic expansion. So, turbine po ito, turbine. So, sa turbine naman, ito po yung equation. If you still remember your thermodynamic processes formula, so sa isentropic process, ito po yung formula. T3 over T2 or the high temperature from the system. Kung ito po yung system natin, then the high temperature, this is the 3, diba? Papasok sa turbine. This is the 4. This is the 4. So, sorry, this is 2. This is 2. This is 2 and this is 3. This is 3. So, pag And this is the work of the turbine. So kung solve po natin yung temperature ng 3 that is PdT2 over T3 is equal to V2 over P3. Pwede rin po ganun. Of course, exponent niya ay since isentropic yan K. The value of hot air is 1.4 over K. Ganyan po yung formula niya. Ito naman T3 over T2 is equal to P3 over P2 is equal over K minus 1 over raised to K minus 1 over K. The same po yan. Ganyan po. Pakaderive na lang ng equation basta yung pagka-plaster niya ay okay na. Okay yan. So, process 3 to 4, of course, babalik po tayo sa temperature constant. But, in this time, rejected na siya. Heat rejected process, isothermal. Okay. So, next is process 4 to 1. Asan na po yung process 4 to 1? Asan na po yung process 4 to 1? Ito. Ito, process 4 to 1. Yung process 4 to 1 ay compressor. So, compressor. When we say compressor, ay constant entropy. So, constant entropy. Constant entropy. That's why the same yung sa formula sa turbine kanina. Halos parehas lahat. Yung number lang ng state yung magkaiba. So, this is now T1 over T4, dapat 1 din po dito. Ayan nga, klaro eh. P1 over P4. Kung kanina po, notice nyo, wala po siyang exponent dito. Pero pag i-derive natin yan, pwede din pong ganyan. T1 over T4. Tatanggalin natin yung exponent dyan, di ba? P1 over P1 over P4 P1 over P4. So, paano pong mangyayari dito? Ano po yung mangyayari dyan? Ayan. Excuse me. So, very basic. So, i-exponent mo lang din yan. Kaya magiging ganyan yan. 1 over K over K. Ayan. Parehas lang din yan mga katropa. So, ganon. Since T2 and T1 and since T2 is equal to T1, T2 is equal to T1 yan and T4 is equal to T3, okay, so ganito po yung mangyayari. V3 over V2, V4 over V1. So, na-notice nyo na wala po yung P at saka temperature. Bakit po nawala yung pressure at saka temperature? Kasi nga po, constant. Then, i-substitute natin yan, nadiderive po yan. Isentropic ratio. So, isentropic compression ratio, of course, pag sinabi natin isentropic compression ratio, meron po tayong compression. So, papasok, lalabas, compressor ito. Of course, kinompress, compression. So, meron tayong compression ratio. Yung compression ratio natin dito is ang V2 to tsaka 3 to. Diba? 1, 2, 3, 4 at tsaka 3 date. Sorry. 4 to. This is 4 and this is 1, 4 and 1. So, notice natin, makukompress yan. So, ang compression ratio natin, of course, yung compression ratio natin always greater than 1. Okay? So, B4 over B1 tayo. So, B4 over B1. Yan. Mas malaki ang volume ni B1 kaysa sa mas malaki ang volume ni B4 kaysa sa B1 kasi dito nga sa graph. Ayan. Volume. Ano si volume? Dito. So, si B1 nandito lang. Si B4 malaki yung volume ni B4. Ayan o. So, yun. B4 saan na tayo? B4 is equivalent to, ang tawag niyan RK or the compression ratio. So, yan. Next, heat addition process. So, heat addition process. Sa heat addition process, so, temperature is constant, di ba sa taas kanina, from process 1 to 2. So, temperature is constant. So, kung ang formula, yung heat addition process natin sa thermodynamics processes, if you still remember, ito po yung formula. QA is equivalent to MR. Ito po, ito yung formula. So, ayan. Sa heat rejection, the same. But nagkaiba lang doon sa value. Kasi sa heat rejection, nasa process na tayo ng 3 to 4. So, P3 over P4 na siya. Okay, nakita nyo. So, the temperature na gagamitin, yung pasok. Yung temperature na gagamitin, yung papasok. Okay, papasok. Since equal sila, ayan, T4 pwede rin. T1, T2, parehas lang naman yung temperature niyan. T3 at T4, parehas lang yung temperature niyan. So, okay lang. So, ang work net natin, sinabi ko na kanina, yung work net natin or the useful work output. So, meaning kung anong pinasok natin, may losses or may reject to the environment, minus yung reject, yun yung net natin. Sa ganito po, work net natin, yung pinasok natin na heat is QA. Yung tinapon natin sa environment, ito yung QR. So, yung malinis dyan ay, yung natira dyan ay, yun yung matatawag natin work net or yung kabuuan or yung useful work. So, doon na equation, substitute kanina sa mga value ng QA at QR, substitute, ito po yung magagawa na formula. Ito na sa efficiency. Sa efficiency naman, work net over QA, always yan. From the general formula of efficiency is equal to, ano po, di ba? Work net or the useful work over the total heat input times 100 to be in percent basis. Okay. So, kung i-derive po na ninyo, ito po ay, kung i-derive mo yan, substitute yung mga value kanina, makakagawa ka po ng ganito. Si T1, T-high natin yan kasi yung mayroon lang tayong dalawang temperature in Carnot cycle. The high temperature or the temperature 1 and temperature 2, equal lang yun sa heat addition natin, process 1 to 2. At saka yung sa baba, sa rejected na heat doon sa temperature 3 at saka temperature 4. Okay? So, pinalitan niya lang ng TH which means T high and T low or the lower temperature. Okay. So, the mean effective pressure naman, ang mean effective pressure natin ay yung average pressure nasa engine. Yung nasa engine, average pressure. So, this is the formula, work net over VD or the work net kanina natin over the volume displaced. The volume displaced. Ano po yung volume displaced natin? Pag sinabi nating volume displace, B3 minus B1 yan. So, saan yung B3 natin? Yung B3 natin, ayan, yung B3 natin. Ito po yung B3 natin. Ito. Minus B1. Okay, yung nasa pag-compress at saka nasa pag-expand. So, B3 minus B1. Yan po yung mean effective pressure natin. Substitute naman po, i-substitute mo yung work net, of course, work net, dito po yan efficiency of the Carnot cycle, ECC, times QA, nandito po yan sa previous ayan, di ba? Ipunta mo dito yung QA, work net na siya. Okay. Okay, then yung sa baba naman, yan yung VD, yung volume displace. Sometimes sa volume displace, that is the pilan or the lancy or yung sinabi natin lancy, VD equivalent to L area then number of revolution sa diesel. So mga rotation yung mga heat engine, yung L ay stroke, ito yung area, or this is supposed to be pi over 4 the area of the cylinder, then this is the number of RPM. Ganyan po sometimes, but dito B3 minus B1. Example kaagad. So example, a Carnot engine receives a 130 BTU of heat. So heat added yan kasi receive. Yan. Heat added. QA yan. QA yan. From a hot reservoir or boiler o kung ano pa man yan na heat reservoir. At 700 yan. High temperature yan kasi sa heat added doon yung TH. TH yan. TH. And reject, yun, rejected, di ba? Sa baba, rejected 49 BTU. Dito pa lang alam mo na may magagawa kang work sa cycle na ito. Bakit? Yung pinasok mo 130, yung ni-reject mo 49 lang, di ba? So mathematically, do your math in your mind, makaka-create ka ng net dito, network. Calculate the temperature of the cold reservoir. Very basic lang to. So di ba? Yan, susulat mo na yung given yan Q added, di ba? Kanina. T high 700 of course plus 460 kasi pag ginawa mo yung absolute temperature, magiging mag-add ka ng 460 to make this unit Rankine. Kasi hindi pwede na hindi mo i-absolute yan. Tilo pa lang ang hinahanap. So solution, the efficiency is equal to, ito yung work net, diba? QA minus QR over QA, or ang formula natin kanina, diba? Efficiency is equal to T high minus T low over T high. Ito mayroon po to, check. Ito given din po, check. Unknown, wala to. Efficiency, wala po tayo, pero isusolve natin yung efficiency. Yan, efficiency is equal to, ano yung efficiency? QA minus QR over QA. QA. Yan, given po yan. Ayan o. Yan o. 130 BTU yan. Given po yan. Ito naman, QR. Ayan. Given to eh. 49 eh. Yan eh. 49 eh. Given din to eh. So, okay. Makukuha pala yung efficiency. Ayun, nakuha mo yung efficiency. Check na yan. So, one equation, one unknown. Susolve na po si TL in terms of Rankine. Yan. Rankine na yan. Yan yung equation nyo. 130, dapat mayroon yan dito. Parenthesis. Okay, ito din po. Mayroon. So, ayun. And the answer will be negative 22.78 Fahrenheit. Okay. Negative Fahrenheit. Okay, next meeting, next video na naman yung auto cycle. So, sa ngayon, yan lang muna yung discuss natin, yung Carnot cycle. If you have a question, if you have some question, please contact na lang sa Facebook or comment below. Yan. Dito po kayo mag-email rptao@bipso.edu.ph. Yan, mag-email po kayo dyan. Yan. Or contact sa Facebook ko, Ramon Lagang Pitao Junior. Ito po yung FB account. Yan. So, kung nagustuhan niyo po yung video, okay, pa-like naman, pa-like at subscribe naman. Yun. Okay, sige, maraming salamat po sa panonood ng video na to. Okay, thank you.